Hi, I'm Marcus Hutzel, and in this Audio 101 series video, I'm talking about expectations of your audio equipment. And I think it's important because, yes, your equipment, your microphones, your professional mixing consoles, your USB audio interfaces, your standalone audio recorders, even the audio inputs on your cameras, they all have expectations in terms of what they want to receive, mostly in terms of audio levels. And our equipment also has limitations of the minimum and maximum levels that they can work with and that they can and expect to receive at their inputs. And if you're not giving your equipment what it expects, your audio can either be distorted, noisy, or maybe even both. So let's talk about it. When we're capturing sound with a microphone and using audio processing equipment like professional audio mixers, USB audio interfaces, standalone audio recorders, or really any electronic audio equipment, that equipment expects and wants certain audio levels at its input or at its multiple inputs if it has multiple inputs. What it expects depends, of course, on the design of that piece of equipment and is usually geared towards what the electrical engineers that designed it expect you to actually plug into it, like plugging a microphone directly into something that has a microphone preamp, or sending a signal from one piece of audio equipment over to another piece of audio equipment. Or with digital mixing consoles or computers where everything lives and travels mostly inside the equipment, that is, sending signals between different signal processors inside the console itself, like from the preamp to the EQ to the compressor, all within the same console. Even just a microphone has expectations. For instance, not all microphones are built for the same purpose, so not all microphones can handle the same sound sources if those sound sources are just too loud for that particular mic. And just like sound waves on the diaphragm of a microphone, inputs on our audio equipment are also rated for and have a range of audio levels that they want to receive, again, at their inputs, so that this equipment can operate at its best and with low noise. And if we give our equipment something way out of range of what it expects at its inputs, number one, you're not doing your job as an audio engineer, and number two, it can lead to things like distorted audio, but most often it's going to lead to noisy audio further down the signal chain. And it doesn't matter if you're recording a single microphone in your home for a podcast or amplifying a band with 64 mic inputs. You need to know your equipment, know what it expects so that it will operate properly and at its best to give you the best results. For example, on this Behringer UM2, if you plug in an XLR cable into input 1, it's expecting a lower mic level signal and you won't clip out usually. But if you plug in a balanced TRS 1/4-inch cable into input 1, it's expecting a hotter line level signal and will pad or reduce the incoming signal so you have more headroom in your gain knob. And these audio levels we send into, through, and between devices ultimately are just small amounts of AC voltage traveling down our XLR cables, our 1/4-inch cables, and our 1/8-inch mini cables, and are generated either by a microphone, which generally comes in at mic level, hence the name, or something usually under -10 dB or under 0.3 volts that kind of relates to mic level, anything under -10 dBV. Or that audio signal can go from one piece of audio equipment to another piece of audio equipment, say from something like a standalone preamp, then sent over to a standalone audio compressor like a DBX standalone compressor, or from, say, a mixing console over to a camera or other video record deck so we can get a mixed audio signal recorded with our video, or even just sending audio signals from our mixing consoles over to power amplifiers or powered speakers. Usually those types of audio interface signals run at line level, or at least should be and expect to run at line level. Now, mic preamps, or most often just called preamps, and the gain knobs associated with those mic preamps are usually the only devices that really expect a low-level microphone signal because, hey, we're using a mic into a mic preamp. That's this preamp's job, is to get this level coming from this microphone up to line level so that the rest of the devices downstream of this can use it properly. The rest of the time, most of our audio equipment expects or wants a hotter line level voltage signal sent between these types of devices. Again, something like between a mixing console and an amplifier or powered speaker, or even a mixing console over to a camcorder that has a proper line level input. Now, granted, some audio equipment has the option to change the level that it expects coming in, but not every piece of equipment has those options. So you have to read the labels, you have to understand what your equipment is doing and what it expects. And this applies to our consumer USB audio interfaces as well that we use every day in our home studios to stream or record, like the Behringer UM2, Scarlett 2i2, Scarlett Solo, Every single input on these devices generally states what level signal it expects at each input and what signal you'd need to try to send it for that equipment to operate at its best or nominally. Now, the easy part is that generally these signals are in two basic forms, again, usually mic level or line level. Of course, keep in mind that mic level, even though it's a lot lower than line level, they aren't always exact voltage measurements because audio signals vary depending on the audio being captured. Not every word of my voice is at the same level. Therefore, even though the average of my voice in this video is at line level, the audio voltage and relative loudness of all of this audio information is still variable within the line level range. Mic level is a range and sits way down here, and line level is a range and just sits a little hotter. I have an entire video about that. I'll try to link it up above, definitely down below. And to recap that quick conversation about mic versus line level, we basically consider mic level voltage just being very low voltage under that negative 10 dBV or 0.3 volt mark. So mic level is down here, and line level being over negative 10 dB and up to about plus 26 dBu, or maybe as much as about 15 volts. And then of course, there's the input of a passive speaker, that is a speaker that doesn't have a built-in amplifier. Passive speakers expect and need an even hotter speaker level signal, and that usually comes from a power amplifier. So in all of these scenarios, microphone to preamp, mixer to outboard gear, mixer to amplifier, and amplifier to speaker, it's important to know your equipment, know its inputs, and what your equipment expects you to send it at those inputs. That's your job as an audio engineer operating this equipment. And the only way to get undistorted and clean audio is to give the equipment what it wants and what it was designed to receive. I see a lot of live audio engineers doing things simply incorrectly. I see them improperly gaining inputs. That's a big mistake I see out in the workforce on a daily basis. Usually they're gaining mic preamps way too low, and the result is that they're only sending mic level signals through the rest of the console and the rest of the system. They're only gaining up inputs a little bit. Therefore, the level that they send through the console and to other processors like channel EQ, the channel compressor, and built-in auto mixers like Dugan auto mixers, that level is just way too low. Therefore, those processors aren't receiving what they want and what they expect. And the result is their EQs, their compressors, their auto mixers, their bus sends aren't going to respond as designed. You're going to have a harder time processing your audio by gaining too low and not giving your console what it wants. And this also produces noisy audio, because if you've only gained the signal a little bit, it's now closer to the noise floor of your equipment. So when it gets amplified later, you'll be amplifying the noise with your main signal. Remember that the gain knob on any professional mixing console, whether it be digital or analog, or the gain knobs on these USB audio interfaces, their one and only primary job is to take the low-level mic signal from a microphone and gain it up to proper line level for either the rest of the console or the computer or anything else downstream of this preamp. That's this preamp's only job on any of these pieces of equipment. Again, consumer or professional audio mixer use in a live environment for bands, corporate events, it doesn't matter. Yamaha QL5, Behringer X32, doesn't matter. Your preamp's job is to gain up every single microphone to a proper line level so that your equipment can use it properly, because that's how the rest of your equipment was designed. It was designed to operate on line level. So that's what we should be giving it with our gain knobs. And this applies to a channel strip on a professional mixing console as well. If you think of the channel strip on any mixing console, analog or digital, the channel strip EQ has an input. The EQ's input comes from the output of what's above it, and that's usually the preamp. And that EQ has expectations of what you're sending it. It wants line level to operate at its best. The same goes for everything that's in line down that channel strip. So if you barely gain up inputs, then you're potentially sending the EQ, the compressor, lower level signal, probably still mic level voltage if you're not gaining properly. And therefore your equalizers, your compressors, your aux sends, your master buses aren't getting what they're designed to want. They're not getting what they expect. So they're not going to work as effectively or as efficiently. Just think of the channel strip as a series of input to output to input to output to input to output. It's a chain of devices that are simply installed in a single piece of equipment, analog or digital. It's your job to pay attention to what the internal as well as the external pieces of equipment expect at every point in the signal chain. The actual electrical engineers that designed our electronic audio equipment did their job, and with labels and usually a hefty user manual, They are literally telling us what this equipment expects and what it wants and why it expects certain things. It's our simple job to give our equipment what it expects. So I encourage you to not only read the labels on your equipment and understand what your equipment does and what it expects, but also practice. Take a step back, get back to basics. It all starts usually at the microphone, and your gain structure goes forward through that chain, never backwards. And as long as you've got good, strong signal early in the chain and you understand what the next piece of equipment wants, you'll be able to produce strong, undistorted, clean audio every time. And your equipment will operate properly without you having to wonder why some part of your equipment isn't working or why your audio doesn't sound like you think it should. Audio is not only about our ears. Our equipment has meters on it so we can verify that our signals have good, strong, proper audio voltage levels after it enters our equipment. Because I don't know about you, but I can't see voltage, at least not without an audio meter. Use the audio meters, listen with your ears, verify with your eyes, know what your equipment expects, and give it just that. All right, good luck. Now, I expect you to practice. I expect you to read your labels, know what your equipment wants, what it expects, and I expect you to give it that every time. And I would like it if you gave me some feedback below. I hope this has been helpful. So until next time, later.